Virtually all products we use are born from powders and grains, such as the pasta we eat. The ceramics we bath on is made of ground rocks. The batteries we use have lithium powder. The pills we take are made in a pill press. And who doesn't recognize the bricks we play with? Very often grains get stuck while flowing and we don't really understand why. We don't have a good scientific understanding to predict grain flow and its clogging. This needs to change. One challenge is that grains are diverse. They can be frictional, sticky, elastic, have different shapes and so on. All these microscopic aspects very much influence their collective flow behavior. Now, a European team of scientists is working together to understand granular flow behavior. They collaborate to combine advanced microscopy experiments and computer simulations to advanced theory. To understand grain flow, we often study how grains flow in a simple cylindrical container with an opening at the bottom. Understanding such silo flows is technologically significant and a very revealing scientific test. Hagen quantified in the 1850s how dry grains have unique flow behavior in such a silo. 100 years later, Beverlo clarified this flow behavior further and made what is now known as the Hagen-Beverlo law for silo flows. To study the role of particle properties such as friction and deformability on silo flows, the Caliper team uses hydrogel beads. Surprisingly, we found that hydrogel spheres have fundamentally different flow behavior from dry grains. Computer simulations can be calibrated to understand the difference in flow behavior. We find that as the silo discharges, the pressure above the orifice is constant for frictional hard grains because of dynamic arch formation. Hydrogels are soft and slippery, so the pressure above the orifices changes from the filling height, and so does the flow rate. With this microscopic insight, we can develop better methods to improve silo flows, such as placing obstacles at strategic distances from the silo opening. Future work will focus on studying grain flows in very small silos and on improving simulation methods. The Caliper Training Network develops expertise to understand the flow behavior of granular materials.